Hello students, we'll discuss in this video the multiplication rule for probability. Multiplication rule is written as the probability of A and B equals the probability of A multiplied together by the probability of B. Now this, we have to be very careful of, is only possible if A and B, whatever those two events are, if A and B are independent. So something in the question has to tell you or indicate to you that events A and B are independent. If they are, then we can multiply them to figure out the probability of both things occurring. If they don't tell you, then we can't use this rule, and later on in the next section we'll talk about a rule we can use to multiply the probability of events when they are not independent. So let's look at an example. Now, as I said, the question has to specify if two things are independent, unless we're talking about coins, dice, or cards with replacement, because those things are always independent. But if we're talking about anything else, then something in the question has to indicate that two things are independent. So let's look at a couple examples. Say we have two dice. We want to calculate the probability of rolling two sixes. So the probability of a 6 on the first dice and a probability of 6 on the second dice. So we'll let A represent the first dice roll and B represent the second dice roll. We know, because we're talking about dice, that those two things are independent. So the probability of rolling a 6 on one dice is 1 out of 6. The probability of rolling a 6 on a second dice is also 1 out of 6. So the probability of rolling two sixes, a 6 on one dice, and that's your keyword, and a 6 on the other dice is 1 out of 36. Just like before, when we could multiply outcomes of each event in our counting rules to get the total number of outcomes, we can do the same thing with probabilities if they are independent. So let's look at another example when we're talking about two other events. So let's say that A represents a hot day, and B represents a sunny day. So let's assign probabilities. Let's say the probability of A equals 0.4 and the probability of B equals 0.5. So we want to calculate the probability of a hot and sunny day. So that's our symbol. The keyword is and. Both of those happening at the same time. We would write it as those two multiply together. 0.4 times 0.5, which would equal 0.2. So that's probably the first thing you're going to, kind of the answer you're going to get, is you're seeing two probabilities for the two events, 0.4 and 0.5, and we're asking for the probability of both of them happening, A and B. And we look at our formula sheet, for example, and we see that formula, so we multiply them together. However, this is not going to be the right answer. It's because these things, those two events, are not independent. If we're talking about coins, dice, or cards, we know those things are independent. Something in the question, if they're not talking about coins, dice, or cards, has to indicate to us that those two events A and B are independent. Nothing in this question tells us that A and B are independent, so we cannot multiply them. So the answer would be insufficient information. We don't have enough information to compute the probability that A times B or 0.4 times 0.5 equals 0.2, because they could be influencing each other. Typically on a sunny day there's a higher probability of a hot day, or vice versa. So keep in mind, something in the question has to tell you if those two events are independent.